Today's lesson we are covering chapter 16, section 1, matrices. This is including and preparing for Algebra 2, Standard 2. Now, Standard 2, we've already done a lot of this in the beginning of the year by solving 2 or 3 variables using substitution, graphing, and linear combination. But we're revisiting this topic now in chapter 16 to learn how to solve them with matrices. So our objective today is to first of all learn and understand what a matrix is and what terminology and vocabulary apply to a matrix. A matrix is a rectangular array of numbers enclosed by square brackets, and plural for the word matrix is matrices. The numbers in a matrix are called elements or members, and we have the number of rows that are going horizontal and the number of columns going vertical, and that determines the dimensions of the matrix. So a matrix that has m rows and n columns is a matrix whose dimensions are m times n. You can remember this if you think of the phrase RC cola, rows versus columns. For the name of the matrix itself, we use a capital letter, and then we use subscripts to represent how many rows and columns there are. So we could have a matrix who we're calling A, and we represent that with a capital A, and then subscript 2 by 3 telling us that this matrix has 2 rows and 3 columns. So here are some examples of some matrices we're going to look at. And what we'd like to do is have us identify the dimensions of the matrices listed above. So as we look at this first matrix, it contains of 3, -10, 1/2. So let's think for a second about what the dimensions of that matrix would be. First of all, how many rows and how many columns? Well, if that's matrix A, let's call that for this sake, then it's a 1 by 3. There is 1 row going across horizontally and 3 columns going up and down vertically. Our next matrix, if we call this matrix B, has 2 rows and 1 column. So matrix B is a 2 by 1 matrix. Our next matrix, let's call that matrix C. It has 2 rows and it also has 2 columns. So in that case, we call that matrix a 2 by 2. Now we'll be talking more later in this chapter that if a matrix has the same number of rows and columns, it's called a square matrix, and there are certain things we can do with a square matrix that we cannot do when a matrix is not square. Let's look at matrix D here as our last sample. This one has 2 rows and it has 3 columns, so matrix D is a 2 by 3 matrix. Alright, let's talk about square matrices some more in particular. A square matrix, we said it has the same number of rows and columns. There's another matrix that's a special matrix called a zero matrix. It's a matrix, no matter what the dimensions are, all of the elements are 0. So if we're asked in this case to write example 1, to write a zero matrix that has 2 rows and 4 columns, and let's give this matrix the name capital E. So this matrix would look very much like exactly like what we've shown on the screen. It's matrix E, 2 rows, 4 columns. So here's the first row going across the top, second row going across the bottom, and there are 1, 2, 3, 4 columns. Well, how can we tell if a matrix is equal to another matrix, or if 2 matrices are equal? Well, 2 matrices are equal if and only if these 2 conditions apply. First condition is that they have the exact same dimensions, same number of rows, and then they have the same number of columns, and that all of the elements in the corresponding positions have to be the same. So here are 2 matrices that it seems like we're stating the obvious here, but there are 2 rows 2 rows, and there are 3 columns in each of those 2 matrices. If we look at the first element in the first row, they're both 5s. The second element in the first row, they're both 7s. Third element in the first row, they're both pi's. In the second row, the first element, they're both 7/8, and then the square root of 2, and then negative 10. So that's what it means to have 2 matrices to be equal. We can use that to solve this equation, or to set up equations and solve example 2. We are told that these 2 matrices are equal because there's an equal sign between there. They both have 2 rows. They both have 2 columns. As we look, the second element in the first row is both -1. The first element in the second row is both 4. We can conclude from our definition we just had a second ago that x plus 5 must be equal to 2. We can also conclude that 6 must be equal to 3y. So what we need to do is to set up equation then. X plus 5 must equal 2. And let's solve that equation, subtracting 5 from both sides. That tells us x must be -3. Our second equation, well, we know that 6 and 3y must be equal because they're in corresponding positions. So if we divide both sides of this equation by 3, we find out that y is equal to 2. In general, let's look at a matrix whose dimensions are m by n. Remember, that's the number of rows first, then the number of columns. They both have to be positive integers. And we use subscripts to refer to the elements. So this element is in row 1, column 1. This next element is in row 1, column 2, row 1, column 3. And then since we haven't decided on the dimensions of these, means we're going to continue out till we get row 1, column n. And then we go down to row 2, column 1. And the element in row 2, column 2. The element in row 2, column 3, etc. out to the element in row 2, column n. And as we progress, let's say this is row m, column 1, row m, column 2, row m, column 3, and eventually row m, column n. So that describes the position of each element in a generic matrix whose size is m by n. And that's our first look at matrix terminology for today's lesson, Chapter 16, Section 1.